Welcome to another interesting video where we will understand how do we figure out increasing interval or decreasing interval for the given function in equation form or when the derivative of the graph is given to us. You can always join my classes by sending an email on the address given. Enjoy the journey of success. Let us understand the concepts now. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss the concept about increasing and decreasing intervals. In case you want to learn from me, you can send an email on the email address given here. We'll analyze for increasing and decreasing interval from two cases, from equations and from graph of derivatives. To illustrate the concepts, we have two examples here. The question is, find increasing, decreasing interval and possible local extrema for the following. Question 1. F of x equals to x cubed plus 6x squared minus 20. Question 2. Graph of derivative f prime x is given to you. You can always pause the video, answer the question, and then look into my suggestions. Let us understand the basic concepts before getting into the solution of this question. So when I say increasing and decreasing interval, what are we trying to analyze? Well, if I have a function y equals to f of x, in that case, the derivative f prime x gives us the interval for increase and decrease. If the derivative is greater than 0, then the graph of the function is increasing. If the derivative is less than 0, then the graph of the function f of x is decreasing. What really is a boundary between them is when the derivative is either equal to 0 or when the derivative does not exist. So that becomes the boundary between the two. So wherever the derivative is equal to 0 or it does not exist, there could be a change in increasing or decreasing behavior of the function. Is it clear to you? And therefore, we have this condition, f prime x equals to 0, or when f of prime x does not exist, we call this as a critical number. So this is called the critical number. The value of x at which the derivative does not exist or the derivative is 0. So to find the increasing and decreasing interval, we basically find the value of x where the derivative is 0 or it does not exist. And then we analyze it using interval table. And that is how we find increasing and decreasing intervals. So I hope the concept is clear. Now, let's get into the working of this and see how it really works out. In question number 1, we are given the function f of x equals to x cubed plus 6x squared minus 20. Let us find the derivative of this particular function, which is going to be 3x squared plus 12x. To find the critical number, we can actually factor this and we get 3x, x plus 4 as the other factor. So that becomes the derivative in factored form. So in this case, when is this derivative equal to 0? Well, this derivative is equal to 0 if 3 of x equals to 0 or x is equal to 0, or if x plus 4 equals to 0 or x equals to minus 4. So we have two critical numbers here which are 0 and 4, right? How did we get that? We equated the derivative, which is 3x times x plus 4 as 0. And then we found the critical numbers. So now we have the critical numbers. Let me write down here. We have critical numbers which are x equals to 0 and x equals to minus 4. These critical numbers will be analyzed. So what we see here is that we have two critical numbers. These two numbers divide the plane in three intervals. Plane means coordinate plane, right? We will analyze these three intervals. So let us have a look at it. So what we are saying here is that we have two critical numbers. One is 0, the other one is minus 4. So let us say this is x equals to minus 4 and this is x equals to 0. So that gives you the interval from minus infinity to minus 4, and this is from minus 4 to 0, and then we have from 0 to infinity, right? We can take test points in these intervals. You have done this interval table earlier in functions, right? We'll apply the same concept. Now the test point on the left side of minus 4 could be minus 5. In between minus 4 and 0 could be, let us say, minus 1. And beyond 0 could be 1. Now, at this test point, we will analyze the factors of our derivative, which are 3x and x plus 4. So 3x will be negative for the first two values, but positive for 1. X plus 4 is going to be negative for minus 5, but positive for minus 1 and 1. When you multiply these two, you get the sign for the derivative itself. Now this derivative is going to be positive when two negatives are multiplied, and negative when there is only one negative and one positive. Both positive means that the derivative is positive. Derivative means positive means the function is increasing. You get the idea. Negative means decreasing, and then positive means increasing. So clearly, we have our increasing and decreasing intervals, as you can see from the analysis of the first derivative, right? So that is the analysis. Now, can you write down the result? Well, here is the result for you. So what we figure out here is that we have a local maximum here. Since it becomes increasing, so we have a maximum value, right? L for local. And then we have a local minimum value since it changes from decreasing to increasing. So now we can write down our answer, which is we have increasing interval from minus infinity to minus 4, and then from 0 to infinity. We have decreasing interval from minus 4 to 0. And how about the local maximum and minimum? We have local maximum at x equals to minus 4, and we have local minimum at x equals to 0. Do you see that? So all this information you can get from the analysis of first derivative. Is this concept clear to you? Perfect. So with the help of first derivative, we could answer this question. Now, here is our question number 2 to make things extremely simple. However, I find this question to be more confusing to students than we expect. Here is the graph of derivative. Let me remind you, this is the graph of derivative of the function f prime x. You need to now tell me the increasing interval, decreasing interval, possible local extrema from this graph. You can pause the video, answer the question, and then look into my suggestions. Now the solution here is very simple. Increasing means what? Increasing means that the derivative should be greater than 0. We can see that the derivative is greater than 0 in between these intervals, right? So the answer should be from where to where? If you think it is from minus infinity to 0, it is wrong, right? If you think it is this interval, increasing, it is wrong. Increasing interval for the graph is, let me write down, from minus 1 to 2. At 2 it is 0, so we will not include 2. And then from 2 to infinity. Because here the derivative is greater than 0. And the decreasing interval is when f prime x is less than 0, which is from minus infinity to minus 1. Is that clear to you? So the first one is increasing. And the second one is decreasing. Now we can write down the local maximum and the local minimum also. Can you tell me what is local maximum here and what is local minimum? Well, the local maximum and minimum is at the point where f prime x is 0, right? That is the critical number. So this could be either of these points. Now if you look here, what is happening here? The derivative is negative. It changes from negative to positive. That means the function is decreasing and then increasing. So that means at minus 4, we have local minimum. You get the idea? So at x equals to minus 4, we have local minimum. At the other critical point, it is positive on both the sides. It is increasing and increasing. So at this point, we do not have any maximum or minimum. So there is no point where we have a local maximum for this particular graph. So this is none. Do you see that? So it's kind of very important to understand how do we find increasing and decreasing interval from the graph of the function. It may be easy but difficult to interpret many times. I hope that helps. With that, we come to an end of this interesting video. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.